Okay, now let's look at discharging. Okay, the way we discharge a static charge, static electricity, is usually by earthing. In earthing, we use a conductor. So, if for example we have a charged object like this, charged object, if we connect conductor to the earth like this, we call it earthing. So in this case, because there are positive charges on this object, let me do this being an insulator, not allowing charges to flow. If it does, then no problem, charges will flow, and this will be a metal, a conductor, metal. So what will happen here is the charges are going to flow from the earth to the metal object. Strictly electrons. Electrons are going to move from the ground through this conductor to neutralize the charge on this metal object. Another way of discharging is the one that we discussed earlier, rubbing. So when a charged object is just laid there, so another method is through rubbing. If we have a charged object like this, if it comes into contact with a negatively charged object or a neutral object, it gets discharged. Also, an isolated charged object, supposing we have an object just like this, negatively charged, over time it will get discharged, usually by air particles. It's going to ionize air particles until it gets discharged completely, so it cannot stay charged forever. It will discharge on its own by ionizing air molecules. Okay, now let's look at lightning. When you have clouds and they ramp against each other, they can develop a very large charge on them. Many clouds rubbing against each other. Some might be negative. So what happens then is these charges will attract the negative charges. If this is positive, it will attract negative charges from the ground, and this causes air, because the electric field between the cloud and the earth will be now strong. This is earth, right? This is earth. So in that case, the electric field becomes so strong that now the air becomes a conductor. And what we see as lightning is actually a discharging of clouds. So the lightning is actually the charges flowing from the ground or to the ground, which will always be negative charges, right? Well, now let's look at a lightning conductor. A lightning conductor. Well, here is our lightning conductor. Lightning conductor. So our lightning conductor has a metal plate which is buried in the ground, and it is constructed such that it has a larger surface area here. The reason is that it increases surface area for what? For discharge, of course. Discharge. And then this is a copper strip. Why is it a copper strip? Because it is a good conductor. It has to be a good conductor. And we have the spikes here. Why spikes? Why sharp spikes here is to concentrate charges. That's the sole purpose of the spike, to concentrate charges. Actually, charges have a tendency of concentrating at sharp points. So what really happens here, as we can see, we have a cloud which is negatively charged here. It's negatively charged. The lower part of it is negatively charged. So what does it do? It repels electrons from this lightning conductor. So electrons will move downwards. They move downwards to the lower part, and they will be discharged to the ground. And then what do we have? We have more positives charges at the spikes, right? There are more positive charges here. So because there are more positive charges, and also we have air around here, so the air around here is going to be ionized. Ionized means the air is going to lose electrons, because the electrons will be attracted to the positive charges here. And remember, this force is far much stronger, so it's able to strip the electrons from the air molecules. So the air molecules will be ionized, will be positive. And what do? They are now repelled. These positively charged molecules are repelled up. And what do? They go up and they reduce the negativity of the cloud in a way, because those stream of positive air molecules, they will now be attracted to the cloud. They are trying to neutralize it, okay, to neutralize the cloud, or to reduce the negativity of this cloud. So if at all the lightning does strike, we are protected by this lightning conductor still if the air molecules did not reduce the negativity of the cloud or discharge it. If the lightning does occur, we are protected by this lightning conductor because copper is a good conductor. So the charges will always prefer an easy path than the building. So one thing that you should notice is the lightning conductor is taller than the building, right? It has to be taller than the building because the charges, as they go down, they have to get to the lightning conductor before the building. So what happens then? The charges will flow through the conductor to the ground. That's our building is protected. If we don't have a lightning conductor and this happens, these charges, they are going to try to use the building as the conductor to get to the ground. But because the building is not made of metal, all of it, so what is going to happen is going to try to resist the flow of these charges, and this force is very strong. In the process, it is going to destroy the building because the force is just too strong. It's just pushing with a greater force, and in the process it damages the building, just like what happens when the lightning strikes a tree. A tree is not a good conductor so the force is just too much to be stopped by a tree, so it destroys it on its way down. So that is what happens. So that's it about lightning conductor. The next thing that we should be looking at is electric field. Let's look at electric field. So here it is, electric field. Electric field. Electric field is a region around an isolated electric charge where the electric field can be felt by a charged object. Electric field. A region around an isolated electric charge where electric force can be felt by a charged object. The field lines have both magnitude and direction. They always move away from positive charges and move towards negative charges, as shown here. So here we have patterns of field lines around an isolated electric charge, as you can see. So if we have a negative charge, we will have something like this. They are coming in. They are coming in. If it's a positively charged particle or object, we will have something like this. So these lines, they originate from the positive charge and end at the negatively charged object. So then fill lines around unlike charges will look like this. So as you can see, this is positively charged, this is positively charged. So if we have something like this, positive, 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 negative, 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 so positive. So what we have is something like this, from positive to negative, from positive to negative. Well, that's the end of our video. The next thing that we shall be looking at is electrostatic induction, separation of charges. So let's start a new video straight away. Thank you for watching.